Assalamualaikum and a very good day to all. So in this video, I will show you how to solve a problem involving rate of change. Okay, so the question is, if the radius of a spherical balloon decreasing at a constant rate of 0.5 centimeter per second, find the rate of change or find the rate of decrease of its area when the radius is 50 cm. So first, we let R is equal to the radius, and then A, capital letter of A, is equal to the area. And then from the question, we know that we have the spherical balloon. So we must know the area of a sphere. Okay. So to solve this kind of question, we must know the formula that we want to use. Okay, so the question wants us to find the rate of decrease of its area, which means we must find dA over dt. Okay, rate of change of area dA over dt, and by applying the chain rule, we know that dA over dt is equal to dA over dr multiply with dr over dt. Okay, so this is the formula that we can use to solve this question. Okay, so given in the question, given in the question is the value of dr over dt from the first sentence. Okay, we know that dr over dt is equal to negative 0.5 centimeter per second. Okay, from the first question, we know that negative 0.5 centimeter per second is the value of dr over dt, because the sentence is the radius of a spherical balloon decreasing at a constant rate of 0.5 centimeter per second. So 0.5 is the rate of change of radius, and the value is negative because in the question stated that the radius is decreasing. Okay, so that's why the value of dr over dt here is negative. And then from the last sentence, we know that the radius is equal to 50 cm. It is also given in the question. So from this formula, we already have dr over dt, which is negative 0.5 centimeter per second. So now we must know what is our dA over dr. Okay, so dA over dr can be found from the formula of area of a sphere. So we know that area of a sphere is equal to 4 pi r square. Okay, so from A is equal to 4 pi r square, we can find the dA over dr. dA, we differentiate the area with respect to r, the radius. So we have 8 pi r, because the power of r we must reduce by 1 unit, minus 1. 2 minus 1 is equal to 1. Okay, so dA over dr is 8 pi r. Now, from all the information here, we can substitute into the formula. Okay, so we substitute into the formula. So we have dA over dr, dA over dt. We substitute into this formula. So dA over dt is equal to dA over dr. dA over dr is 8 pi r, and then times with dr over dt is negative 0.5. And then we can see here we have r R is already given in the question, which is 50 cm. So we substitute the value of R. So 8 pi times 50 cm and then multiply with negative 0.5. So we will get the value is negative 200. Okay, 8 times 50 times negative 0.5 will give you negative 200, and pi we just write here. So negative 200 pi centimeter square per second. And again, we get the value of dA over dt is negative because the rate is decreasing. Okay, so this is the solution for the question involving the rate of change. Thank you very much.